everyone. Here's a little bit of a different problem. In this problem, we are doing a stoichiometry problem with gases. Now, this might look a little intimidating, but the process really isn't that different from what we've been doing all along. So let's look at that problem. What volume at STP of fluorine gas could be produced by the decomposition of 9.22 times 10 to the 24th molecules of POF3? So POF3 is decomposing, and it tells us in the problem it's forming fluorine gas, and we know fluorine gas is F2. And what's going to be left over, if we pull out all the fluorine, all we have is phosphorus and oxygen, phosphorus oxide. Okay, so we got to balance this equation. We've got the odd-even rule. We have an odd number of fluorines on the left and even on the right. So let's start by putting a 2 here on the left-hand side. That gives us 6 fluorines. So we need to put a 3 in front of the fluorines on the right-hand side. And let's not forget to balance out the phosphorus and the oxygen. Since we have a 2 here, we're going to need a 2 there. So now we have a balanced chemical equation. So far, nothing different than what we've done so far. Okay, so now we're going to start out with our 9.22 times 10 to the 24th molecules of POF3. And again, you need to convert it to moles. And we know there's 6.02 times 10 to the 23rd molecules per 1 mole of POF3. And we need to go to moles of fluorine gas. So we're going to put moles of POF3 on the bottom, moles of fluorine gas on the top. We get the coefficients from the balanced chemical equation. So it's going to be a 2 down here, and it's going to be a 3 up here. Now I'm out of room, and we're going to need one more conversion factor. So let's just continue this over here. And our last conversion factor, we're going to have moles of fluorine gas on the bottom. And it's asking for volume. And you may remember from last semester, at standard temperature and pressure, there's 22.4 liters per mole of gas at standard temperature and pressure. So let's look at what we've got here. Molecules of POF3 cancel, moles of POF3 cancel, moles of F2 cancel. When we do our math, it's going to be 9.22 times 10 to the 24th divided by 6.02 times 10 to the 23rd times 3 divided by 2 times 22.4. So let's put that in our calculator here. So we've got 9.22 times 10 to the 24th times 3 times 22.4 divided by 6.02 times 10 to the 23rd divided by 2. And when we get this all done, we get 515 liters. Okay, so what's similar about this problem is that you start by writing the formulas for the components. You balance the chemical equation. You take the molecules and convert them to moles. Then you put in your mole ratio, and the one thing we did differently this time is you had to remember from last semester that there were 22.4 liters of fluorine per 1 mole fluorine. And I hope that makes sense. Bye.